I'm Anil Kumar. Welcome to my series on sequences and series. Now, in this very important topic is to discuss about arithmetic and geometric mean. We have 5 questions related to this topic. In question number 1 and 2, we'll understand what is after all arithmetic mean and what is geometric mean. Question number 3 is a simple example to calculate arithmetic and geometric mean. And question number 4 is show that geometric mean of two positive numbers a and b is less than or equal to the arithmetic mean. Now this is a very important test question. So I'd like you to really understand the topic. We will try to prove it in two different ways. One will have a geometric approach and then we'll have algebraic approach. Question number 5 here is a multiple choice question, which is if g is geometric mean of a and b, then 1 over g square minus a square plus 1 over g square minus b square is what? 4 options are given to you. Now this is again a very popular multiple choice questions in many related test papers. So I hope you find this video very interesting and useful. Let's now see and understand what arithmetic and geometric mean really are. So question number 1 is if a, x and b form an arithmetic sequence, then find x. So we have 3 terms in this. One is a, the second one is x, and the third one is b. So we are saying they are arithmetic sequence. So arithmetic sequence really means what? It means we have a constant difference, right? Between consecutive terms, correct? That is what arithmetic sequence is. So that means x minus a should be equal to b minus x. Clear? Now we need to find what x is. So let's bring this x to the left side. We get x plus x equals to, taking a to the right side, a plus b, right? So which is 2x equals to a plus b, or x is the average value of a and b. Do you see that part? So this is what arithmetic mean is. It's kind of an average value, right? So in short, we can always write that arithmetic mean is basically add the terms and then divide by the number of terms. In this case, the mean is equal to a plus b divided by 2, right? Now we extend this to even more number of terms. So if there are n terms, in that case, arithmetic mean can also be taken out by adding all the numbers. That means if we have terms like a1 plus a2 plus a3 till let's say an, then their sum divided by number of terms is what arithmetic mean will be equal to. Clear? So that is a general definition for arithmetic mean, and this is the basic concept, correct? So basically add the 2 terms and the middle term is average of the those 2. Perfect. Now let's see what is geometric mean. Now we have a geometric sequence in which there are 3 terms given to us. We are saying a, x and b form a geometric sequence. Then find x, right? For positive values of a and b. Okay, so geometric sequence, we have these 3 elements, a, x and b. So in geometric sequence, their ratios are constant. So we have a constant ratio, right? In geometric sequence. So that is what the condition is. It really means that x over a should be equal to b over x, correct? So this ratio is constant. If you cross multiply, you get x square equals to ab, right? So x square is always positive. Now x could be written as square root of AB. So when we need to find what geometric mean is. It is basically square root of these two terms, right? So basically we now get the definition of geometric mean, which in this case is square root of the two terms, correct? Now this, as we did in the previous case, can also be extended to n terms. So this could be extended to, let's say if we have a1 times a2 times a3 till an, then the nth root is the geometric mean. Is that clear to you, right? So that becomes the general formula, right? So I hope the concept is clear. Now based on this, let's have a very simple question, which is find arithmetic mean and geometric mean for the following numbers. Okay, so let's find both arithmetic and geometric mean for these numbers. You can always pause the video, answer this question, then check with my solution. Okay, so let's do arithmetic mean of these two numbers. Basically you add them and then divide by 2, correct? So we have what? 20 over 2. So we get our answer as 10. As far as the geometric mean is concerned, you need to multiply them and then take square root, correct? So 4 times 16 square root, correct? So it basically is 2 times 4, which is equal to 8, correct? So that is the geometric mean. Perfect. Now similarly, let's find arithmetic and geometric mean for these two numbers. So as far as arithmetic mean is concerned, just add them up, which is 3 plus 24, divide by 2, which is 27 by 2. So we get a fraction or a decimal number, right? So 26 would have been 13, so this is 13.5. Now to get the geometric mean, we need to just multiply them and take square root since we have two numbers here. So 3 times 24, right, square root. Okay, so 24 is 3 times 8. Okay, so we could write this as, let me write this as 3 times. 24 could be written as 3 times 8 is what? 4 times 2, right? So 4 times 2, correct. Now this way if you write, it becomes easy to do square root. Square root of 3 is 3 and 4 is 2. We get this as our answer. So we get 6 square root 2 as the geometric mean, correct? So that is how you could calculate arithmetic mean and the geometric mean. So whenever you have this kind of a question, it's kind of important to reduce it to the lowest terms and then write down the answer. What you notice here in both the cases is that arithmetic mean was greater than geometric mean, right? Now normally that is the case. But if we have both as same numbers, correct? But if we have the case where the numbers are, let's say 3 and 3, correct? In that case, arithmetic mean will be equal to geometric mean for the same numbers, correct? Okay. Otherwise, arithmetic mean is greater. Okay, so let's take the fourth question now, which is extremely important question. I'd like you to pause the video, copy this question, and then look into my suggestions. One of the most important topic here is to understand arithmetic and geometric means and the relation between them. So we'll look into this inequality that arithmetic mean is basically always equal to or greater than geometric mean. So in this video, we'll kind of prove it. And we'll use two different methods to prove. One approach will be geometric and the other will be algebraic. Now what you could consider is that let's consider a circle. Now in a circle, let's take diameter of the circle. So we have a semicircle now. Within semicircle, let's take a point anywhere on the circumference. If you join this point with the endpoints to the diameter, in that case, you will get a right angle triangle, correct, in a semicircle. Perfect. Now, from this right angle triangle, let me drop a perpendicular. Now, in general, this will not go through the center, right? Now, let us say that this diameter is divided into two parts, A and B, with this altitude or a perpendicular from the third vertex, which is at 90 degrees, with these two sides. Let's call that side as C. Okay, so we have this particular circle with a diameter. So what we have here is the diameter is equal to A plus B, right? Now, let us sketch this slightly bigger. It's too small actually. Okay, so we are just sketching the same thing slightly bigger. Purposely, I'm not making this in the center. In general, this point could be anywhere, right? So it's somewhere, but not in the center. Is that clear to you? So we have two sides, A and B, right? So this is A and that is B. So what I'm trying to say is that the diameter is sum of A and B. Let's call this as H. Now you will notice that since we have a 90 degrees right there at the vertex on the circumference hemisphere, this angle is theta, which will be equal to that angle, correct? Since that is 90 minus theta, right? So this and this angle are same. 90 minus theta, that is theta, same angle, correct? So in the given situation, let me label this as AB. Let's say this point is P. So in this given situation, the triangle, let's call this point here as D, okay. So the triangle ADP is actually similar to triangle PDB. Since the angle ADP is congruent to angle PDB and the angle PAD is congruent to angle DPB. Right, so both are same angles. So from AA properties, so that is similar because of AA property. Since they are similar, we could write ratios are same, right? So we can write side opposite to that other angle is A divided by side opposite to this is H should be equal to side opposite to this other angle is H in the other triangle divided by B. So cross multiplying gives us AB equals to H square, right? So from here we can write that square root of AB is equal to H. So we get one condition. That square root of AB is equal to H. Okay. The other condition which we have here is that A plus B is equal to diameter. AB, right, is the diameter. Correct? And from this given figure, you can see that H is less than A plus B divided by T, 2, right? Because it is not the radius, right? Radius will be when you join the center, then you get the radius. So height is less than, or it could be at the most equal to. If this happens to be right in the center, we could have height same as the radius, right? But half of the diameter, which is the radius, is definitely more than the height, right? So from here, you can clearly see that h is equals to square root of ab, and this second equation says that a plus b divided by 2 is the radius, right? Since the radius is bigger than h, at the most it could be equal to. We come to a conclusion that a plus b over 2 is greater than or equal to square root of ab. Is that clear to you? So that is your arithmetic mean, and this is your geometric mean. That is how you prove it, right? So as a special case, they are equal. A plus b over 2 is equal to h, or I should say square root of ab, if h equals to r, the radius. Do you see that? Because then they are both radius, right? Only then they are equal to. Otherwise, the average or the arithmetic mean is greater. Is that clear to you? So that is how we are going to prove it. Now let's also try to prove the same using algebra, right? Okay. So what we will do here, that we'll do a kind of substitution. Let us say a square is equals to x and b square equal to y. Okay, so let's assume this, right? And we are given that a and b are both positive numbers. In that case, what is going to be x minus y whole square? Whatever, it is definitely going to be greater than or equal to 0. Is that clear to you? Now this could be written as, rather let's take a as x squared, since I am starting with x squared minus y squared, and b as y squared. We'll begin with from, right? So let a be equals to x squared, b equals to y squared. In that case, x minus y whole square is a positive quantity. It has to be greater than equal to 0. So when you expand this, you get x squared minus 2xy plus y squared should be greater than equal to 0. Taking this to the right side, we get x squared plus y squared is greater than equal to 2xy. Now x squared is a, so we can write this as a. Y squared is b, so let's write this as b, is greater than equal to 2 times what is xy? Xy square root of ab, right? Or dividing by 2, we get a plus b divided by 2 is greater than equal to square root of a plus b. Is that clear to you? Right? So making this substitution, a equals to x squared, b equals to y squared, we can actually algebraically prove that a plus b over 2 could be equal to or greater than square root of ab, product ab, right? So that is to say that once again, arithmetic mean is greater than equal to geometric mean. Is that clear to you? Now here is a very important multiple choice question, question number 5. If g is the geometric mean of a and b, then 1 over g square minus a square plus 1 over g square minus b square is what? So what we are given here is that g is geometric mean of AB. That means g is equal to square root of AB, correct? So in that case, g square should be equal to a times b. Perfect. Now what we need to figure out is what is the value of 1 over g square minus a square plus 1 over g square minus b square. Now g square is ab, so I could write this as 1 over ab minus a square plus 1 over ab minus b square. Now here we can actually take a common, right? So we get a times b minus a, and here we could take b common. So we get a minus b in this case, right? Now taking b minus a as a common denominator, you could actually write this as common denominator will be ab, right? Let's take the common denominator as a times b, both, right, times b minus a. Now if b minus a times ab is your denominator, we have to multiply this by b, right? So we get b here. Now in this case, we have taken b minus a, here we have a minus b, right? So that means we get minus a here on top, correct? Now as you can see, what we get here is that these two terms, they cancel, right? And we get a result which is 1 over AB. So option C is the right option, clear? That is how you're going to do it. Well, let me show this step, last step once again. Let's multiply this by B, right? Both of them. So we get B over AB times B minus A, right? Now, here we'll multiply by A. So we have A over AB times A minus B. Do you see that A minus B and B minus A? So if I take B minus A as my common denominator, this sign is going to change. So we have B minus A and they cancel away. Clear? And so we get 1 over AB as the result. So that is how you're going to answer this particular question. So I hope that helps. Feel free to write a comment, share your views, and if you really like and subscribe to my videos, that'd be great. And I think these concepts are absolutely clear. Thanks for your time and all the best.